Hey everybody, this is the setup for our conservation of energy lab with the marble. So real simple, have the wooden block this way, kind of like hot dog style, but the higher of the two, not laying flat, and then put your ruler over the top. So the idea is the marble is going to be our object. Use the larger steel ball. It's about 15 grams, so you'll be able to use that for a measurement, but convert, of course. And the idea is we're going to place it up here at rest and release it so that it rolls down this hill or this ramp we created. The goal in the first part of the lab is to predict, with conservation of energy, predict the speed it'll have when it leaves the hill. So to help you out, the top, the very beginning, let's call that the initial or starting point. So think about what energy it'll have when I actually place it at rest. And based on that energy, you can then make a measurement, possibly. And then as it rolls down, think about what's happening with the energy, what it's transforming into, and then the bottom will be our final location, which should have a new type of energy that it transformed into. All right, again, one more time, you're trying to predict the speed through calculations down here when it leaves the hill, and that'll be the first major part with conservation of energy. Once you finish that, then I actually want you to check your prediction with video physics. So you guys are going to set this up and pretty much put your iPad kind of how mine is. Make sure you can see the entire ruler because we're going to have that be our scale. Don't worry that it's at an angle. Remember, the scale is just counting pixels in your screen, so it'll apply it in any direction. What you want to do though when you then set up video physics is you want to actually track the object first, the steel ball, once it's left the hill, left your ruler ramp. So maybe 6 to 10 data points down here. And then when you go to create a graph, let's do a position versus time graph, keeping in mind this should be in the X dimension, the X component. So if you do a position versus time graph, you should be able to get this speed by, I'm going to leave that on you guys, see if you can remember that, okay? But from the graph, you should then be able to check what the actual speed was and compare it to what your prediction was with the energy conservation idea with the hill. All right, read the lab thoroughly. I think you guys will be pretty successful on this, but take your time and, of course, ask each other for help if you need it. Good luck, guys.